we want to use this video to show you how our system architecture is built, what we are developing inside the company, how we are training our neural nets, and how we are going about design. So I guess we should start with what we wanted to build. And I think everybody is familiar with AI agents and different companies which tell you that they have AI agents which can do everything for you. But I guess at this time, even if you're like more into the technical part of AI, I think you already know that a lot of AI agents, quote unquote, are not very agentic. They're actually, just making your hard life even harder. So what we set out to do is we wanted to build something that inspired us from the time we grew up. So basically Iron Man with Jarvis or the Her movie. So I think everybody of you knows these two movies. And what we can see there are basically a complete different kind of AI from what we get today. So what we see there is typically AI which is actually doing things for you day in, day out, every day, and you don't need to stress about whatever it's doing. So we wanted to do something that's 100% useful and not all about the hype like you see a lot on the internet currently. To do this, I think there are a lot of architectures or a lot of ways to do it, but currently what we see a lot are these flowcharts. So there are a lot of agents which are organized with different nodes and you connect them, and then this is the way how you set your agentic network up or whatever. But what we wanted is a approach that actually everybody wanted to use. We had 3 core challenges. So to do our automation, we wanted that it's completely independent from your machine. So I mean, if you wanted to do something even while you're asleep or your computer is shut off, you have to have it completely independent. It has to be versatile, so it has to work across all your apps. So it can't really be dependent on APIs or MCP availability or whatever. And it should be incredibly fun and easy to use. So back to the topic, even a child or your grandma should be able to use it and they should have fun with it. What we came up with, and that's the part of design what we get later with Leon. I will get him into the frame later on. This is what we came up with. So I guess Leon will tell you a lot about it. What we basically came up with something that very, very much resembles your current operating system in a way. And we wanted to run everywhere, so we put it into a browser. So you actually open it with Chrome. Let's talk about system architecture. We want something that is actually performing the tasks for me and is thinking for me. And then we need a way to interface with that. This is you, the user, and you are interfacing with the brain. Now, the brain has a way to think, but to perform actions, it needs an environment to perform these actions in. So we create a virtual machine where the brain is able to work with. So basically its own environment. And over the time, you see this small dotted line, and that's basically the border from everything below there is in the cloud and everything above is basically on your device. And then we give the brain a way to interact with this machine. So we give it a mouse and a keyboard. That's it, nothing else. Now you also want to see what happens in the machine. So we also give you a way to look into this. We stream the content inside the virtual desktop, not only to the brain, but also to you. Then we come to a part that's quite interesting because obviously it should work with all your pre-existing apps without being dependent on your machine. This needs basically a new kind of app store, a app store which allows you to install all kinds of apps. Across all devices or all platforms. Like you find in there Mac, Windows and web applications, Android, whatever you need. And you can one-click install them and then they're running on there. And even if you can't find it in the App Store, you can just upload applications. Okay. I guess we're to the part where we get into intelligence. For that, I wanted to introduce Hannes, who's part of our intelligence team and deeply connected with training the LLM and benchmarking the LLM.
Hi, Max. Thank you for introducing me.
Sure.
And showing the system architecture of our product. Now I'm here to tell you something about our intelligence system and like the human brain of our system. To use an agent as your digital worker, you have to have some kind of playground where the agent can work and interact with. This is the system architecture Max just introduced you to. Now we have the second part, which is like the brain, the human or the logical brain, which needs to be adopted to the playground in order to understand how to use some kind of actions like clicking or pressing a button or taking a screenshot. But let's start with the fundamentals.
Maybe what's important to understand before we go into our neural net training process and so on is that the whole system is completely controlled visually. So the model is basically using a keyboard and a mouse just like you are doing it with your computer, and then it's not using some fancy API stuff or something. It's literally just vision input. So it's completely the screen captured, vision input and mouse and keyboard movement output. So that's the basic layer how our LLM, vision LLM is interacting with our system. So yeah.
The open source models are required to take vision input and text input to be able to understand what they're actually controlling, and understand the video recording of the virtual machine. Therefore, we built post-training pipeline to enable the LLM or open source LLM to interact with the actions we defined in our playground to make it use the click actions and so on. So with this post-training pipeline, we are able to fastly adapt to newer open source models with better understanding of the world just by applying these models to our tuning pipeline. Let's go a little bit deeper into our training and the 3 stages we have in our training pipeline. The first step we call the instruction tuning. This step of the training process, we introduce the different actions of our playground to the model. So the model now knows how to use the cursor, how to use the keyboard, or to even speak to the customer to tell him that it needs some additional information or something else. The second step of our training stage is to introduce some kind of reasoning into the model so that we can enable the LLM to think more strategically. For this training, we used like the ODA loop as a blueprint. This ODA loop is a cycle of a thought process to always think of or evaluate the current step and think of what's the best next step and how do I get to the goal I'm going to achieve next. The ODA loop consists of 4 different stages. Firstly, you have the observation state where you assess what were my last actions, did I completed them? So
and this is also the step where it's actually looking at a screen. So observation includes looking at my history, like what have I done before, but also this is the step where we ingest the screenshot or the live screen capture of the process of the system.
So there it is able to validate if the last steps were successfully executed or if it did some mistake. And if after it's done that, it can go to the second step, the orientation phase, where it can like model different ways to go on to get closer to the goal. After it modeled different ways to get closer to the goal, it decides which one is the best and then takes the next action. The third step of our training stages is to insert some kind of application knowledge so that the model knows how to use a certain software like Google Presentation or SAP or anything else, and then is able to like build certain business processes and create value. To put this kind of training into our model, we use reinforcement learning, where we give the model access to the application, and then it just can play around and look, on this website I can do this, or on this page I can do this, and I get there by this path, and this person list is to be found there, and it can run in any error and learns out of this playing around what's the most efficient way to execute a certain process.
So maybe to give a general understanding of how it's working, the system basically at this step learns how to interact within our system. Before it just learned with next token prediction like every LLM would, but with this step it basically gets put into our environment, like in our operating system, and there it has to use the tools it has available in order to achieve its goal. And I think it's quite funny to think of that step of like a speedrunning process. I mean, essentially it's the same thing. We give it a goal, like finish this task, and then we spawn, and that's super cool. We spawn like hundreds of different agents which have the same task, and then they are off to the races. Like they have their own strategies to achieve different goals. And then after the fact, we just rank them and see, okay, who was the fastest and most efficient, and who had no errors along the way, who has done everything perfectly. And with that, we basically create kind of a speedrunner who's able to do every task super efficiently.
Whenever you implement a new feature, or in our case, train a new model, you have to have some kind of validation or tests to check how would this affect our product. And for testing LLMs, it's quite hard or like computationally demanding to benchmark a system. We came up with an SDK that uses our product from the terminal, so we can give it a list of tasks that is executed and then evaluated by different performance metrics like tokens it needed to use, or some different actions, or the amount of different actions it needed to use to solve the task. When we trained a new model, we can use this benchmark to evaluate how the performance of new models increased or decreased. So with our internal benchmark system, we have some kind of way to build end-to-end tests and evaluate new models.
Oh yeah, as a last thing, maybe that's something we didn't even talk about yet, which just came to my mind. This SDK, we are working currently on the open source version of an open source version for the SDK. So very soon you will be able to get a research license from us, and then you're freely able to use our whole infrastructure and our models and training pipelines and the environment to do your own training of your own model or data generation or just research on agents. Yeah, I think that will be quite cool.
Yeah, I think so too, especially for scientists who want to evaluate our product.
Yeah, it's everything you need, like from data generation, optimization, training, evaluation, everything in one pack.
Yeah, that's all from my side.
Okay, yeah, these are just some graphs I put into our presentation to maybe give you a feeling on what are we looking at when we train our models. And this is literally something this is the reason why there's like a gray bar which is blocking some internal informations up there. But I literally just pulled this out from an internal report. And here we are especially comparing two models. One model where we tuned or trained the vision attention heads, and one where we freeze them and didn't train them. And here you can clearly see that the vision model is outperforming the non-vision optimized model in nearly every category. And some which are very important for us. Obviously, this is just to tell you, this is a click benchmark. So we're looking at, okay, how big is the error rate for a given model in our click benchmark? And obviously something very interesting is always the average distance to what we would expect the model to click to where it actually clicked. But also the average distance doesn't tell you a lot. It's just a nice glimpse, a first glimpse. What we're very interested about oftentimes is like this within 10 pixels. So you basically take the area of interest and then you like have a boundary of 10 pixels and then you look at how many runs got into this border area, and you want to shift like from 20, 50 pixels, and we have like multiple buckets. You want more and more clicks to be within these ever getting tighter circles to see that the click precision increase. The most, like at the end, the most interesting number we look at is the bounding box hit rate. That's the bounding box of the element you were supposed to click. And then we actually don't really care where you clicked in the element as long as you hit it. And that's basically a hit rate. And here you can obviously see that the vision model outperformed the non-vision optimized model in a long way. So then we did some internal testings with our own click benchmark where at least we think it's quite a good benchmark and maybe even the best on the market, but unfortunately not open source, so you have to trust us at this one. So first what you can see is this is click performance what you would get if you are just doing random clicks. And then we benchmarked some OpenAI models against our current models. And what you see is that the nano model is, I guess, as you would expect, quite bad. And then the models which are more optimized for computer use, especially like the OpenAI agentic operator, which is available via the API in some form, is the best of the pack. But because obviously it's a little bit of a fair comparison. Within our environment and our test, our models are the best. And I think that would be to be expected. But this maybe tells you that it's not so easy for us to just use some random LLM. There is really a huge benefit for us to do this post-training step for the models and reinforcement step of the models within our system to really get them tuned into our system and to perform this good. Like here we have, at the current moment, we have a average click error of 7 pixels. So whenever the model is clicking, it's nearly perfect hit. Okay, yeah, and that's it for Hannes, unfortunately. Okay. And I would ask Leon to join me at this point for our next session of the UI UX design, I guess. That's also something that's, yeah, very exciting and interesting. We try to do something new. Yeah, let's get Leon on the stage. Okay, I mean, UI and UX is probably, at least also for me, one of the most important things. Because at the end, we want to reach a lot of people, a lot of everyday people, and like not tech nerds like you and me who's probably watching this. So I'm very excited that I think we found a very nice way to take the things we already know from our operating systems and spin it in a completely new way to enable the user interface to do something completely new and give you the opportunity to understand what it's doing at the same time.
Exactly. And now let's talk about design. So in the creative design process of warmwind OS, we always followed the simple and minimalistic approach. As mentioned earlier by Max, using our product should feel intuitive and easy for everyone. This is one of our core principles.
Okay, when we look at this, I think it's very new for a lot of people. I mean, for us, we are kind of familiar with it, looking at this for nearly a year now. What would you say, what are some things we took from other operating systems, and how does this incorporate with the optimal user or our goal user who should be able to use the system?
So the general design of one of our workspaces is very simple. It's basically split up in separate parts. So there is one area that is related to the user. This is down here, a area where you can change your space, a main input element to interact with your assistant, and also a button to access your profile settings or general settings. Then you have this main content for your assistant, which most importantly are the app windows or the different app instances, but also the app bar or the assistant area down here, which are like the connection parts or bridges into your workspace of the assistant, because you can interact with them and like modify the app, go into the app store, or get access to the latest message of your assistant. And yeah, so these are some special
I think something we really have to keep in mind is that we are not looking at typical operating system. A typical operating system, be it your phone or your computer, is completely used by you. So everything you see on the operating system UI is there to interact with you and to be interacted by you. But when we look at this, and maybe I go back to the slide where we see it all. When we go back to this, we can see that we split into different parts, because obviously there is an area where your assistant is working. So it's not particularly designed to be used by you all the time. I mean, you can, but most of the time it's just a window into the world of your assistant where you can see what he or she is doing. But then also obviously there's an area where the assistant has no access to. So changing the name of your profile, like your billing settings, your invoices. That's obviously something that's like, from a theoretical point of view, it's one layer above. It's something where you manage all your agents, like billing settings. And I guess that's the idea why we split it up into like this outer and inner area. And the outer layer is then used to manage your overall account or your view. And I think these connection parts are then used to connect the inner and outer layer, right?
Yeah, we want to show how simple and fun our product is to use. And now we just hop into a workspace of ours.
Okay, live demo. Yeah, okay, here we are in the browser.
All right, so this is the first impression when you get into your space. We can show the little animation here. And as you can see, you are prompted to install your first app. You can do this by simply clicking here, and now you get access to our internal app store.
Let's install Firefox.
Install Firefox. It's that simple. You just install your app and it is ready to use. And now you can open it manually, or the assistant can also do when you prompt it. And there it is. You can install like more apps, for instance, Gmail or Google Calendar, and you can have them open simultaneously, and you can also switch between them easily.
I oftentimes even use like the swipe gesture for the Mac. That's also very nice, at least for me.
Yeah, sure.
But that's obviously only things we're doing as a human in there. Maybe we can like give the AI one task to see like where the layers are splitting. What's the area of the AI and what's the area of me. Let's install Amazon and let's give it a task to research something funny. Maybe the best price value for 10 kilogram of salt.
That's a good task. Now we can hit enter.
So what we see is that is changed to like a stop button. Mm-hmm. What's the idea behind that?
So as a user, of course, you should always be able to stop the assistant if something goes wrong or whatever.
Maybe you can tell us about the task list?
Yeah, as you can see now, after entering the prompt, your assistant created a working list consisting of different steps. You can access them by just hovering those little buttons here. And yeah, now you can keep track or see what the assistant is gonna do next.
Yeah, I love this feature. I think we will see it soon. Like it's actually moving over, like it's done, and then it's moving over to the different other side. And I personally love this feature because it gives me like one glance and I see where it's at with its current task. Maybe tell us about the cursor. I guess that's a very cool feature, or nicely designed.
So the cursor, as you can see here, is like the assistant's own cursor, and
so that's the blue dot, right?
Yes, exactly. That's the blue dot moving here. So yeah, you can see every action the assistant takes by just following the blue cursor that's moving inside of an app window here. And yeah, like every action is visualized. So if he scrolls, if he moves, if he clicks, as you can see here, it's just scrolled. As a user, you can see it.
So when you hover over the app and you can see this dark overlay, what does it say down there?
So it says click to interrupt assistant, because it is designed so only one or either the assistant or the user can interact with the app. Otherwise, it's not possible.
And it's not blocking you, right? So when we get a like search for 100 kg salt. So I can still go in there and then I can literally interrupt, like click,
You have to click on the extra button. Otherwise, you could just switch the focus of the app windows if you had multiple open.
So I think it's important to realize that you're still in control over the window. You just can click here and then you're in complete control over the window. You can do things. The cursor is still there. It just stopped. And when you're done with whatever you're doing, you just click resume and the agent takes over from there again. Okay, maybe we can abort the current process. Are there things you are maybe you find particularly interesting or cool for maybe aspiring UI designers out there?
Well, obviously, we decided to use this glass design in a lot of places. Maybe we can show the user settings as a good example. So this is like this cool glass morphism style, and yeah,
I also like the small animation.
Yeah, that's a new feature. It's like every interaction is beautifully animated, as you can see. Also the hovers, or like here accessing your different spaces.
I think what people are, it's easy to underestimate how hard it is to create all of this in a web environment, right? Obviously, if you're Windows or Mac, you have a lot of control over the individual pixels. But for us, we have to keep it performant. But at the same time, we are constrained to Chrome, basically.
Yeah, sure. So animating in a good way is pretty hard in the web environment.
So what time would you say, like when you have a typical workday, what percentage of time do you have to put into animating or cleaning up animations against like the general layout of a new feature?
I think most of the time I'm just iterating and adjusting easing functions or like timings, so the animation is just or feels perfect. And it's hard to say, but it takes some minutes to.
So there's not really a mathematical process behind it. It's really just a feeling.
Really.
You have to spin loops and try again. Okay.
Mostly it just has to feel intuitive and good, and yeah, if you do it a lot, you're getting used to what feels good, and obviously this feels good.
Yeah, it's very smooth.
Yeah, you're also able to like change your assistant if you want to. We have some options here.
And I guess it's important to understand that changing the assistants is really just a theme, so it's just a style. Because the idea is you will have multiple assistants and you have to have a way to tell them apart. And so that's the only way we thought would be reasonably cool. So it's basically just a theme you pick for different agents, but they are not like smarter or different really from a technical perspective. I think something what's actually quite interesting is that you don't have a chat history here, right? Typically you interact with an AI with a chat history, but here we basically the only thing we have is like these small responses down here, but you don't have your typical like sidebar chat history, what you would have in most AI tools.
Adding a history all the time would look a bit off and it would destroy our minimalistic look. So we decided to hide it a little bit or integrate it down here. So if you just want to access the history, you can click here, and now this assistant area extends, so you can just scroll and see the previous messages.
And the funny thing is that people are actually not even using the chat history. Like that's the point why we decided that most of the time we won't need a chat history. So we're about to scrub it completely. Because obviously, what are the main reasons why you would need a chat history? Basically just to remember what have I done last. But at the same time, there are so many indicators that can tell you what you have done last. Like the process list, you see what were the last processes. You have like all the UI state, you have the windows which are open. So everything you need to know is already in there. And if not, you can just ask your agent, like why not? Typically, a chat history is most useful if you chat with humans, like WhatsApp, Discord, whatever, because you don't really want to annoy the other person with asking, oh, what did you send me last week or whatever. You just scroll up, but for an AI, like who cares? You will not be able to annoy the AI, at least with our fine tuning. Let's go into the teaching mode. I think that's one of the coolest features actually, because maybe one word before that. The idea is how can I increase my bandwidth from my brain to the brain of the AI? Like how do I tell the AI what I want it to do for me? And for most AI agents, that's typically just chat input. It feels like we could just show the AI what to do. So that's exactly what we've done. We just take its hand, like its cursor, and guide it along the way. Okay, let's show off the teaching mode. I guess that's a cool feature. And let's teach it how it gets our current YouTube subscriber count from our channel.
All right, so you can access the teaching mode down here in the main input. by clicking the Teach button. And now you can see the space background changed, your cursor changed, and it's now watching and listening to your action. Now I just want to open YouTube.
So it's literally watching your cursor. So it's watching you doing things and learning it from it in real time.
So now we're there, and we can also see down here, there are now a little indicator that your voice is actually getting recognized.
Okay, yeah, and let's accept the cookies.
Of course, we accept all the cookies, so we can use it. Now you see there's also a little indicator that your current step is processed, so the assistant can remember it. Now I want to click just here and search warmwind OS, which is our YouTube channel. Then you click on the channel name, and now you can see the subscriber count next to your account handle.
And we can even prompt it with this mode. So we can even say, okay, and please go there every day and get us this number and send it to me via email or put it into a Google Sheet, something like that. And after that, we just click stop, and then it's basically saved to the knowledge of the AI.
Exactly.
Yeah, okay, thank you, Leon. Thank you, Hannes, who's at this point behind the camera. I think our main objective with the video was to inspire you and show you how we are doing things behind the scenes to get all the to get a product in the current stage you're seeing it here. And if you feel inspired, if you want to work on something related to this, and if you have maybe ideas to even more improve on the current state of the system, definitely consider applying. We're looking for a lot of people who can help us with that and scaling it up and making it better and better. Thank you for watching, and see you next time.